This is a little video about atoms. It's a review of class on September 30th, 2020. So we started by talking briefly about matter. And we know that matter, based on the last couple weeks in class, can either be pure or it can be mixed. If it's pure, it's called a substance. A substance means that it has only one identity. If it's mixed, then matter is either homogeneous or heterogeneous. Homogeneous matter only exists as solutions, homogeneous mixtures only exist as solutions. And heterogeneous mixtures can be all sorts of things, all mixed up. Get a little bigger field of view. Okay. Now, if it's a pure substance with a single identity, it's also homogeneous because it's the same throughout. Like a solution is homogeneous, but a solution is two things. Pure substances are homogeneous with only one identity. And there are two examples of that. One of them is compounds, and the other is an element. All right, if it's a compound, compounds are made of molecules, or sometimes they're called formula units, but I'm not going to go into that right now for simplicity's sake. And elements are made of atoms. So molecules are more than one atom. That's more than one, usually more than one atom, usually more than one kind of atom, but there are some molecules that exist of the same atoms. So more than one atom chemically combined. And chemically combined means they're doing something with either sharing or transferring electrons. Technically, if they're sharing, they're a molecule. If they transferred, they're called a formula unit, but they are analogous to each other. Very similar. All right, and these guys, compounds, have only one identity because they're pure. An example would be like water. It has H2O in it. It's always two H's and one O. And today we're going to focus on atoms. So I'm going to zero in on this part of the little chart. So matter, it's pure or it's mixed. If it's pure, it's a compound or an element. Elements are made of atoms. We're going to talk about atoms in class today. So atoms within an element are all basically alike. There are some differences, but they're basically the same. They all have the same number of protons. So there are three parts to an atom, and protons and neutrons and electrons. But the atoms of an element have to have the same number of protons. Electrons can change and neutrons can change, but protons have to be the same. All right, so we're going to zero in on what's an atom. Well, atoms have this real little tiny spot in the middle that's called a nucleus. It's a little red spot on my page. And then the atom that goes with that nucleus would be surrounded by, the nucleus is surrounded by electrons, and the electrons are constantly moving, and they're not in any one definite spot. As a matter of fact, they're so little that if you see them, light bounces off of them and they go somewhere else. So you really can't see an electron and know where it is. We never really know where electrons are, but we know that electrons are somewhere around the nucleus. They're kind of like a ceiling fan. There's the blade of a ceiling fan only are like 6 inches wide, and there's often a foot between the blades, and so there's plenty of room for you to stick your hand in between the blades, But if the ceiling fan is on, then you can't get your hand between the blades without getting hit because the blades are moving so fast. And that's the way electrons are in the atom. All right, so this little thing in the middle is called the nucleus. And inside the nucleus, there are two parts. There are the protons and neutrons. And outside the nucleus are these fast-moving things out in here. These are called electrons. All right, I'm going to make a little chart here about protons and neutrons and electrons. So protons, neutrons, electrons. We're going to say location and make a little table, charge, and mass. Okay, protons are in the nucleus. So they're going to be in that little red dot. And the charge on a proton is positive. Neutrons are also in the nucleus. And the charge on neutrons is 0. They don't have a charge. And the electrons are outside the nucleus. They're in the electron cloud. The electron cloud is this cloudy-like thing around the nucleus. Outside the nucleus in the electron cloud. Okay, and the charge on the electron is negative. So the red dot is positive. Let's write that in. And outside the red dot is negative. We'll write that in. Now let's talk about mass. Protons and neutrons both have a mass of 1 atomic mass unit. An atomic mass unit is a number that, or a scale we made up in order to compare things on the atomic level. It's kind of like if you, the atomic mass unit scale is kind of like if you had, you all know who Mr. Hopper is, and you all know who Ms. Dunn is. So if we had Mr. Hopper and it said, well, he has a mass of 5 because we don't really like his weight is about 180, but we're just going to say 5. And then if Ms. Dunn weighs about 115, so if I did 115 divided by 180, that would be comparing Ms. Dunn to Mr. Hopper. She weighs about 64% as much as he does. So times 5 on our new scale, Ms. Dunn would weigh 3.2. Okay, so that's just a PMU scale, just giving you a quick example. So AMUs are done like that. We define carbon as having a certain weight in grams, and we say it's 12. So instead of actually giving the weight of carbon, which is like 10 to the negative 20-something grams, we just say it weighs 12, and everything else is relative to carbon, carbon atoms. All right, that's 3.2. My writing's a little sloppy. Okay, so anyway, bottom line is they have a mass of 1, each one of them do. So all the mass is in the nucleus. So the mass is here. The electrons don't have a mass. They have a mass, but it's so small compared to the protons and neutrons that we say it's 0. So it's like 2,000 times smaller than this. So we don't even count it. We just say it has 0 mass. Okay, so I'm going to show you a couple things online here. So let's go to my website, and on my website we have a little link that you might want to play with on the homework page. Okay, so we're going to take a look at what an atom looks like. Remember, we talked about protons, neutrons, and electrons. So when I put the protons in, they're going to go on the nucleus, like that. Now notice what's changing as I put the protons in. Do you notice that the element changes? That's because the protons determine the identity. So we could toggle back over here and a few key points. So identity is determined by protons. All right, so go back over here. So right with 3 protons, we're at lithium. If we go to 4 protons, we're at beryllium, Be, and it goes along like that. Okay, I'm going to show you charge and mass. Well, let's talk about charge and we'll talk about mass. So charges, the charged particles were the protons and the electrons. Remember, protons and electrons? They're the ones with charge. The protons are positive, electrons are negative. So if I go back over here and I put in electrons, what's going to happen to charge? Should go down because I'm adding negatives, and see it did. It went to 3. And if I throw another one in, it goes to 2. And if I throw another one in, it goes to 1. And when the protons equal the electrons, the atom is said to be neutral. If it's not neutral, the atom is said to be an ion. See how it's ion up here? Okay. So when the electrons vary, we call those ions. So I'm going to say ion is caused by losing or gaining electrons. Normal atoms have equal protons and equal electrons. Ions are caused by losing or by gaining electrons. Okay, so if I gain an electron, you see the charge. Normal is 4 for beryllium, so if I add another one, then the charge goes negative. All right, the part of the atom I don't have in here yet is neutrons. So I'm going to add neutrons. I want you to watch what happens when I add neutrons. Notice I just put in mass number. Right now the mass number is 4 because there are 4 reds, 4 protons. But if I put in a neutron, what changes? The identity didn't change, the charge didn't change, but the mass did because neutrons have mass. And if I just keep putting neutrons in, eventually it becomes heavier and heavier eventually until it hits what it's supposed to be on the periodic table. So let me show you that. I have a periodic table here on our website, and the periodic table shows the atomic number, which up here, and it shows the atomic mass down here. So for boron, let's see, which one were we building? We were doing beryllium, I guess. No, wait. We're doing beryllium. So if we go to beryllium here, beryllium is right here. It's got 4, and its mass is supposed to be 9. We'd round it off to 9. So if we build it, we'd have to put in enough neutrons in until we got to a mass of 9, and right now we have 8. All right, so that is a normal beryllium atom. It has 4 protons, 5 neutrons, and it's got 4 electrons when it has no charge. I'm going to click this box, says stable, unstable. This particular form of beryllium is stable. Let's see what happens if we add another neutron. That's not a stable form of beryllium, so take it out. Let's see if we take out a neutron, is it stable? And it's not. So beryllium only exists with 5 neutrons. Okay, I'm going to change the element now to make it lithium. So in this case, I've got 3 protons and 4 neutrons, and that is a stable form of lithium. Stable means it can exist that way. If it's unstable, it won't exist because things don't like to be unstable. It's kind of like if you're leaning back in your chair, you can only stay that way for a little while, because if you stop paying attention to it, you're going to fall down, either backwards or forwards. So stable means you're going to be there like all 4 legs are down. Unstable means that you might be on 2 legs or 1 leg, and you can't maintain that. So if I took another neutron out, I still am stable. So you see, for lithium, it can exist with either 3 neutrons or 4 neutrons. If you go to 5 neutrons, it's unstable. If you go to either 4 or 3, it's stable, but if you go to 2 neutrons, it's unstable. So to be a stable form of lithium, you have to have a couple of different neutron amounts that will work. So I'm going to go back here to definitions. I'm going to define this word isotope. Okay, isotopes, they are caused by varying or changing neutrons. So the definition of an isotope is atoms of the same element, they have the same identity with varying numbers of neutrons, or with different numbers of neutrons. So they're the same element, but they have different numbers of neutrons. So they have different masses. Okay. Now this was on the website, so you're able to play with this game with no problem. All right, I'm going to change now to teach you about a notation. And the notation is going to show up over here as I change the protons, neutrons, and electrons. So as I add protons, notice what's changing. The identity does. This number down here changes, this number up here changes, and the charge is changing. If I add neutrons, only the number up here changes. Because neutrons don't have a charge, so they're not going to affect charge. But they do have mass, so they affect mass. The red number is the number of protons. That's the identifier. That's what determines identity. So as I add neutrons, I don't change the number of protons. Now, I don't know if this is a stable isotope of helium or not. Let's see if it is. And that is not a stable isotope of helium, so it wouldn't exist that way. But that one is. I wonder if helium can exist with only one neutron. Yes, that's a stable isotope of lithium. Excuse me, of helium. All right, but this is the most normal. Now, if I throw in my electrons, I make a normal helium atom with 0 charge. Now remember, if I throw in an extra electrons, what's going to happen to charge? It's going to go down. Okay, so that would be a negative ion of helium, which is not likely to happen because when you put this electron in, it has to start a new ring. We'll get into that another day. All right, let's look at a different element. That's lithium. It needs another neutron to be stable. We talked about that. So that's the atomic number. That's the what's called the mass number. All right, so let's define that, the symbols there. So if I have an element, some element X, in position A, we have what's called the atomic number. And that is the number of protons. In position B, we have the mass number. And that is the protons and the neutrons. And in position C, we have the charge. And the charge is determined by the protons and electrons. So I'm going to put normal is 0, P equals E. Losing electrons creates positive charge, and gaining electrons creates negative charge. Losing and gaining electrons is very important in chemistry because it determines how things combine and what ratios they combine in. So once again, if you lose electrons, watch what happens to charge over here. Let's make it normal first. Okay, there's normal lithium. It's got 3 electrons and 3 protons. Let's make it a little bigger. I'll make a bigger atom. Okay, so here's a nitrogen atom. Almost there. We're going to get to be normal. It has to have 0 charge. And nitrogen is not stable with only 3 neutrons, so I'll add some neutrons here until I get it stable. There we go. Okay, now that actually is the most common form of nitrogen. It has 7 protons, and it's got a mass of 14, which means it also has 7 neutrons, because this number includes both the protons and the neutrons. And the charge is 0 because the electrons and the protons are even. So if we go to the periodic table and look at nitrogen, see how it says 7, that's the number of protons, and that is the mass numbers of protons and neutrons. Now, periodic tables don't have to follow this standard notation that I'm showing you here, because they organize based on the protons. They've tried to put it in the most prominent place. And then the periodic table also shows you a charge. Sometimes this one does, and this one shows you the most likely charge that would happen if there was a charge. So if nitrogen was going to have a charge, the most likely one is -3, and how that happens is the nitrogen will gain electrons until there are 8 electrons in this energy level, or this ring, and then that's the most you can have in that ring. So it stops filling, and that's a stable arrangement, and so that's how it exists when it's a nitrogen ion. Okay, once again, when it has a charge, it's an ion. Okay, so that's a little overview of the atom. What I want you to be able to do is play the game and be able to answer the questions quickly. So like right here, you're trying to fill in that number. That's the mass number. So you look in the nucleus, there's a proton and a neutron. So it's got a mass of 2. You check it, and that would be right. On this one, you're trying to figure out what this is. You got 7 protons and 10 electrons, so you got 3 extra negative charges. So it'd be a -3. Here you've got 1 proton, so it's going to have a 1 down here, because this number tells you the number of protons. All right, and I'm going to let you guys play the game on your own, but that's my overview of atoms for Wednesday, September 30th.